Okay. I am recording this event, guys, and I will start with reviewing chapter 1. So I'm just going to give you the main highlights of chapter 1, what you need to know in order to do well in chapter 2, and so on and so forth for chapter 2 on 3. You need to know the definition of statistics, which is actually, there is no one-word definition of statistics. Statistics is about collecting data, organizing data, and analyzing data. Now, we collect data in statistics, and data could be either qualitative or quantitative. Qualitative data is an attribute like a color, your favorite color, religion, sex, race, country. That's called the qualitative. Quantitative is a number, when like they say the number of students in a class, height, weight, that's a number. So if the data is a number, then it is a quantitative. If it's not a number, then it is a qualitative. In statistics, mainly we're interested in quantitative data. So number of pets, guys, what do you think it is, qualitative or quantitative?
Quantitative.
Yeah, because it's a numerical measure. And then we can check the answer and see, nice work. We'll move to the next question. Determine whether a quantitative variable is discrete or continuous. Let me tell you what discrete and continuous are. Discrete is a countable number that you can count only as a whole number, 1, 2, 3, 4, 5, 6, 7, etc. Continuous, it doesn't have to be a whole number. It could be a decimal. So anything that you can measure using a tool, it must be continuous. Anything that is not countable and has decimals in it, or potentially can have decimals in it, then it's not a discrete. So running time of a film, guys. Do you think a running time of a film has to be exactly 1 hour or exactly 2 hours? If it can be 1.5 hours or 1.2 hours or 1.3 hours, then it's not discrete. And the running time of a film can be, it's not discrete, it's continuous, because it can be a decimal, it can have a decimal value. I'll give you an example of discrete. Number of students in my class. I can't have 3.5 students. It's either going to be a 0 student, 1 student, or 2 students, or 3 or 4 or 5. You see, it's a whole number. So if we answer running time of a film, the variable is continuous because it's not countable. Countable, guys, something you can count on your finger and go 1, 2, 3, 4, 5, 6, etc.
So I had a question about that as well. With that, can't you technically like count minutes or seconds and they'll be like whole numbers?
Well, yeah, but I can tell you is what happens after 1 second. Does the second come, or it could be a 1.23 seconds, you know, in race. Okay. You know what I mean? So I know what you're saying, but that's a good question that you asked. Very good. If we can do what you said, then it is countable. It will be discrete. But remember, there are fractions of a seconds. You know, in race, they do fraction of a second, then it's not discrete anymore. That was a very brilliant question. I like it. Okay, next question. Determine the level of measure of a variable below. Let me tell you about the levels of measurement, guys. Data, either it is qualitative or quantitative. For qualitative data, guys, now I'm going to use my stylus. A qualitative data, these are labels, attributes, are not numbers. Okay, there are 4 levels of measurement. I'm going to show you. So data can be categorized as a qualitative or quantitative. But if it is a qualitative, guys, it can be categorized as nominal. Let me tell you what nominal means. Nominal means data is qualitative and it cannot be ordered. You cannot put the data in order. For example, guys, if I tell you what's your favorite color and you give me a list of colors, which color do I put first? Why red should come before blue, should come before green, etc. Then in this case, we call the data at the nominal level. So it's a qualitative data, but cannot be ranked. No ranking. Ranking means to put it in order from highest to lowest, the smallest to largest, etc. Now, there is another type of qualitative data called ordinal. Data mostly is qualitative, but can be ranked. Can you guys think of something that is not a number and we can still rank, put them in order? What can you think of? What do you think the letter grade, guys? A, B, C, D. Do you think we can rank them? Do you guys agree with me that A comes before B, comes before C, comes before D? That's an example of ordinal. Or strongly agree, neutral, don't have an opinion, disagree, strongly disagree. That's another example of ordinal. So now you know the difference between nominal and ordinal. Okay, just 1 second. There are 2 other levels. As you can see, guys, you're reading 4 levels in the answer. For quantitative now, and that's what we really are interested in. There is a level called interval, and let me tell you what interval means. Data is quantitative. It can be ranked from smallest to largest, largest to smallest. But the 0 at the interval level means something. So like if I tell you I have $0 in my wallet, that means I don't have any money. But the 0 at the interval level means something. So I'm going to give you an example. So 0 means nothing, something. Can you give me an example of a data, some data that you know of where the 0 means something?
Temperature.
Exactly, you nailed it. Temperature is the most famous example for this. So when you know, guys, that the 0 means something, it is data at the interval level. And temperature, definitely 0 means something, because in the winter, guys, I prefer the temperature to be 0 rather than 20 below 0 or -20 or -15. So that's interval. The last level, guys, which is the most important level to us, is the ratio level. The ratio, the data is quantitative. 0 means nothing. It's the 0 that we know of, guys. It means nothing. Data can be ranked. Data can be written as a ratio 1 in terms of the other. So anything that is not interval, guys, that's not nominal, that's not ordinal, must be ratio. I'll give you examples: weight, height, you name it, money, dollars, time, etc. This is all ratio. When I say 0 minutes, means 0 minutes, nothing, no time. When I say the weight is 0, that means the weight is 0. There's nothing here. $0 means nothing. But 0 temperature, no, it means something on the scale. And now we'll go to our example, guys. The volume of water used by a household in a day. What do you think the answer is going to be now?
Ratio.
Yep, it is ratio indeed. And then we're going to move to the next question. Okay. Oh, I put it twice, so it's ratio. All right. Now let me tell you the difference. Now in statistics, we do 2 types of study. We do experiments and study in statistics to make conclusion about a question that we are trying, to study and find an answer to, or we do observation. Let me tell you the difference between an observational study and an experiment. How do they do an experiment? For example, just when they experimented, with the COVID-19 vaccine, here's how they do it. They bring 2 groups, guys, for the experiment. One group is called the control group, will get no treatment, nothing. They usually give them, just placebo, water, pills, for example, if they want to try a new medication. One group will get nothing, and another group will get the treatment. This is called the treatment group. They'll get the actual medication. And they monitor, you know, the two groups, and they will check later if there is a difference between the two groups. If there is a difference, that means whatever they're trying to do means it's effective, is working. If there is no difference between the control group and the treatment group, that means whatever they're trying to do, it's not showing any signs that it does make a difference. So that's what an experiment is. An observational study, guys, means you observe and take notes. You don't do any interference and then make conclusion, you know, just based on your observation. So we're just gonna clear the drawing here and try to answer this question here. 7th grade students are randomly divided in two groups. Well, that's a good hint now. One group is taught math using traditional techniques. The other is taught math using a reform method. After 1 year, each group is given an achievement test to compare proficiency. What do you think this is, guys? Design. It's an experiment, exactly. There you go, right here. So that's the difference between experiment and an observational study. Okay, here you go, right here, guys. 50 patients on dialysis are divided in two groups. One group receives an experimental drug to find cancer, the other a placebo. Placebo, guys, is a water pill. After 2 years, kidney functionality is measured. You can see this is definitely an experiment because one group is getting nothing and the other group is getting the drug. And all right, so that will be the one. Okay. Now, in statistics, guys, we want to study the population. The population is like, let's say, I want to survey the residents, the students at Henry Ford College. There are 13,000 students at Henry Ford College. We cannot survey all of them. That's not possible because it does cost money and it does cost time and we need manpower. And you guys, you know that we do the census, which is the survey of the entire United States once every 10 years. Why do they do it every 10 years? Because it costs so much money, billions of dollars, you know, just to do it. And it takes 10 years actually to prepare for it. So if you have a question about the population and you need to answer the question, the population means it's a collection of all outcomes, all data. You cannot just survey the population. You, simply speaking, you know, it's not just realistic, you know, to survey the entire population. So we pick a sample. A sample, guys, is a subset of the population. For example, if I want to survey the students at Henry Ford College, rather than surveying 12,000 students, probably I can pick a sample of 300 students and then survey them. But the question is, how do you select the sample? I cannot just go to the biology department and get 300 students from the biology department. That wouldn't be fair to other students. What about if my survey was about something that pertains to biology? So I'm going to get some answers from biology students, probably doesn't reflect, you know, on the answers of the entire population. So when you pick a sample, guys, you have to be careful. It has to be a random sample. That means you have to pick it in a way that is fair, you know, just to all. Like, for example, I have you, let's say 30 students in my class. If I want to pick 5 students at random in your class, and let's say we were on campus, the best way, which is called the random sample, to do it is put your names in a basket and select 5 names at random. This is called a random sample, a simple random sample. So a simple random sample means, guys, every member of the population has the same chance of being selected. So you need to be aware of it. For example, let's say I have a class that has 20 male students and 10 female students, and I want to pick a sample. And I want, you know, just the female students to be fairly represented, you know, just in the sample. I think you should agree with me, guys, that I have to pick twice as many female students as male students because their number is doubled in the population. So this is what we call a fair random sample. Not all samples that you see in statistics are random, guys. Most of the samples that you see, the commercials, the promotions, the marketing, are all biased samples. But now after you take this course, you're going to be able probably to criticize, those samples and wonder whether they're showing you what they're showing you, just is really a simple random sample or not. So let me give you the definition of the correct. Sorry. Let me give you the definition of the correct answer right here. A sample of size n from a population is obtained through simple random sample if every possible sample of size n has an equally likely chance of occurring. Then in this case, the sample is called a simple random sample. So if I want to pick 5 students out of a group of 30, the best way, guys, to do a simple random sample, put the names in the basket or put the numbers in the basket, and without looking, pick 5 names. That's a simple random sample. Let's go to the next one. Now, there are 4 different sampling techniques, which I'm going to explain them to you. I already explained what a simple random sample is. Let me tell you about the other 4, as you see listed in there. And that probably will conclude the first chapter. So let me just show you how to work with it. Let me tell you what a stratified sample is. I'm going to explain this first. Let's say this is Henry Ford College students, and I want to pick a sample that is called the stratified. Look what I can do. I can divide the students into measures like math, chemistry, biology, English, sociology, criminal justice. We split them up into measures. And then we go to each measure and we select a few students from each measure. So we select a few students from math, few students from chemistry, few from biology, sociology, English, chemistry. And then the students we selected from each major, we put them together, and that's what we call a stratified sample. So you split up the population into pieces. You go to each piece, you get members from there, you select members at random from each piece, you put them all together. That's what we call stratified. Now, let me tell you what a cluster is. So that's stratified cluster. And the other 2 are very easy to get, but let me tell you what a cluster. Let's say we have the students at Henry Ford College. These are 12,000 students. We split them up into measures, just like we did with the stratas: English, math, biology, chemistry, etc. Then we'll go, let's say, to English right here. And we pick every single student who is an English major and make him our sample. Everybody, and we ignore the rest. We ignore the rest of the majors. This is called a cluster. Probably, guys, you think that this is not a fair way, just to select the people. Yeah, that wouldn't be fair if the pieces here are different from each other and they don't have a lot of things in common. That wouldn't be fair. But all of those pieces have lots of things in common, then it doesn't matter which piece you pick to be your cluster sample. So I could pick all English majors, all math majors, another cluster here, everybody in math, and I'll tell them you're going to be my sample. This is what we call a cluster sample. Now, let me tell you what a systematic sample is. That's an easy one. Let's say I have 30 students in my class and I want to select 5 students using a systematic approach. Look what I do. I can wait by the door as the students walk in, let's say at 9 a.m. and pick the first students who walks in at 9 a.m. And then I say to myself, I want to pick every 5th students. So I'll count 1, 2, 3, 4, 5. These students I'll pick. Then I'll wait to see the 6th, 7th, 8th, 9th, 10th students. Then I'll pick and say you're going to be in my sample. Then 11, 12, 13, 14, 15th, and I'll pick that students and say you're going to be in my sample. This is called systematic. You create a system, guys. So that's systematic. We stratified, we cover, simple random. Let me tell you convenience. Convenience is not a good sampling technique. It leads to bias most of the time. And let me tell you what convenience is. For example, let's say I want to survey students at Henry Ford College, and I am in the math building. I only survey students who happen to be in the math building and make it a sample. This is convenience, guys, because I only surveyed the students that are convenient to me, that happen to be in math, and that would be called convenience. Another example of convenience, let's say I have 30 students in my class, and it's a very wintry day outside, and only 5 students showed up to class. And my survey is about how much distance students commute from home to school. I only go ahead and survey, those 5 students who happen to be present in class. That's called convenience. And that's going to lead to bias, because those 5 students, guys, probably came to class because they live very close, just to the campus. And then when you survey them, they're going to tell you that they don't commute much. And then you're going to make an impression that all students don't commute to school. That's what we call convenience. This is not a recommended sample to use, guys. All right. To determine her breathing rate, Kari divides up her day into 3 parts: morning, afternoon, and evening. So her day is divided into 3 parts: morning, evenings, and afternoon. She then measures her breathing rate at 3 randomly selected times during each part of the day. So 3 here, 3 there, and 3 there. And these are her samples. She makes them her sample. What kind of sampling technique are we talking about, guys?
Stratified.
Yeah, it is a stratify, because she did not ignore any of the pieces, guys. Exactly, that's what it means. All right. Yeah, I know I'm going fast, but the idea is just to do a quick review, guys. So to estimate the percentage of defects in a recent manufacturing batch, a quality control manager selects every 17th computer that comes off the assembly. You should be able to tell me which sampling technique is this.
Systematic.
Yeah. 17, 34, you add every 17, it's systematic, exactly. All right, that's very good. Let me clear here. Okay. This is the next one here. Determine whether the following statement is true or false. When conducting a cluster sample, it's better to have a fewer cluster with more individuals when the clusters are heterogeneous. Okay, heterogeneous means they have different values. That's not a true statement, and don't worry just too much, just about it. It's better to have a fewer cluster when the cluster are homogeneous. That's what should the answer be. Because let me give you an example, guys. Let's say there is a disaster area, and the government, just wants to survey, just people who lived in the disaster area to determine how much compensation they're gonna give them. They could divide the disaster area into the following way: into blocks. If the damage is everywhere, they divide it into blocks. If the damage is consistent throughout, guys, the disaster area, cluster is not bad. They can survey, just people who live in this block right here and make a determination about the whole thing based on this. If the damage is the same everywhere, then a cluster is a good idea here. But if the damage is not homogeneous, it's heterogeneous, like here there is so much damage, here there is little damage, here there is a little bit more damage, here 100% total damage, then cluster is not a good idea here, because if they just survey this block, it might not reflect on the damage that happened in the other blocks. So there are times where cluster is good and other times the cluster is not good. All right. Mouse. Okay. Nissan wants to administer a satisfaction survey to its current customers using their customer database. The company randomly select 50 customers and ask them about their level of satisfaction. They use their customer database, the computer, and they pick 50 at random, guys. What kind of sampling technique are they doing? Any guesses?
Simple random.
You got it. Yeah, they didn't mention they divide the population into segments. They just pick 50 at random. That's simple random sample. Random means, guys, you don't do it intentionally. You don't know what's gonna come out. That's what random is. So simple random, exactly. That's the correct answer. Oops, let's go back. Okay. Now biased and not biased, just sampling. Usually your sample should not be a biased sample, guys, but it does happen many of the time that the sample will turn out to be a biased sample. So I'll explain that to you in a second. That's the last question in chapter 1. A polling organization conducts a study to estimate the percentage of households that have internet access. It mails a questionnaire to 1939 randomly selected households across the country and asks the head of each household if he or she has internet access. Of the 1,939 households, only 37 responded. What do you think the bias here, guys? They're gonna make a decision based on those 37 responses. So what kind of bias do you think is this? It's a non-response bias because they didn't get enough responses and they're gonna make their decision on 37 survey that they got back out of 2,000 surveys. That doesn't seem, just to be right and fair. And this is what we call a non-response bias right here. Okay, so if I choose, non-response bias. How can this bias be remediated? Okay, or remedied. Let's see. What do you guys think? To have more people, fill out the survey, what do you think it can be done? Does A make sense? No. The polling should only select households in a single state? No. And let me see and D if they make sense. The polling organization should mail the questionnaire to a greater number of households. Well, if they mail it to a greater number, they're still going to get fewer responses too, because they mail it to 2,000, they only got 37. Should mail the questionnaire to each person in the households. Well, if the main person in the household did not answer, I don't think others are going to respond. So I think it makes sense, guys. They have to try some other ways, to contact the people. Try by phone or face-to-face. So you guys, when you do a survey, don't expect that all people are going to like the way that if you offer them one way, to respond. Give different options for people to respond to a survey, and then they might respond. Okay. All right. Now we're talking about distribution of data. You have data, you collect data, you're going to get raw data, something like that. Let's say I ask you guys, how much do you spend on lunch each week? And you give me, just those information. $3, $7, $5, $11, $12.50, etc., etc. Let's say I have 40 or 50 students and they all give me an answer here. This is called raw data. It's not displayed, just nicely. And if I display data like that, you guys, you wouldn't even be able to make sense of it and answer questions pertaining to the data. So you have to organize the data, just like your schedule, of classes is organized in a table that you get it from us. That's what we mean by organizing data. It's very important to organize data. One way to organize data is through what we call a frequency distribution table. Like, look at this table here, guys. It is about the speed. Okay, the data on the right represent the top speed in kilometers per hour of all players in a certain soccer league. So this is the speed of the player. So let me explain what 10 to 13.9. Speed, so anyone who has a speed from 10 to 13.9 is listed there, and there are 3 players who have this speed. Here we have 6 players whose speed is between 14 and 17.9. Here we have 16, 63 player, 296 player whose speed between 26 and 29.9, and 179. This is called the frequency distribution table. This table has 1, 2, 3, 4, 5, 6 rows of data. They call them in statistic classes. And each class, guys, has a lower bound and an upper bound. Like the first class starts at 10 and ends at 13.9. And I would like you to notice, guys, that there is no overlapping between the classes. Look, this ends at 13.9. This immediate start at 14. No overlapping. 3 is called the frequency. So number of players is called the frequency here. How many players, belong to 10 to 13.9? There are 6 players whose speed are between 14 and 17.9. Now, this is called an interval also in mathematics from 10 to 13.9, but in statistics, we call it a class. Now, if you want to figure out the width of the class, here's how you figure. So how long, how wide the class is. This is what you do, guys. You take the beginning of the second class and the beginning of the first class and subtract them. So 14 minus 10 will give you 4, and that's what we call the class width. So each class has a width, guys, which is the class width 4 here, and you do it this way. You subtract 10 from 14, or you subtract 14 from 18 is a 4, or you subtract 18 from 22 is a 4, and so on and so forth. Okay, so the whole thing is called a frequency distribution table. So to answer those questions, the number of classes we answered that 1, 2, 3, 4, 5, 6. The class limits for the third class, guys, 1, 2, 3. 18 is called the lower class limit, and 21.9 is called the upper class limit. And the class width, I explained it to you guys. You do it vertically. 10 subtract from 14, 14 subtract from 18, you get 4. And you could do 13.9, take away from 17.9, that will give you the class. There is another question that's coming up about this. All right. Now this question, guys, we're going to spend a little bit of time in showing you how to construct the frequency distribution with the first class having the lower class limit of 30,000. So he tells us that the first class begins, guys, with 30,000. So we just type 30,000 here. Okay. Then we have to figure out what number goes here, and then we have to figure out those numbers and so on and so forth. Let me show you just how to start this, guys. In order to construct a frequency distribution table, you need to know the class width. And here's how we determine the class width, guys. We need to know the highest value and the lowest value. And now I'm just going to show you how I can go to StatCrunch and do this. Watch, guys. I open in the software. This is the software that you use in your textbook. Okay. I'm going to sort the data from smallest to largest so I can see which one is the smallest and which one is the highest. So I'm going to go, that's the mouse here. I'm going to go to data, sort. Watch me doing this. Select column and replace. Oh, sorry. Why it didn't do it? Open a new data table. Oh, right here, sorry. Okay. So you can see the data is sorted, guys. This is the lowest value, remember, at 30,273. And the largest one, I'm going to write it down. And the largest one, you can see it's at the top, 52,580. Let me go back to our exercise. Oops, not right here. Assignment manager.
It's in a different window at the bottom.
Yeah, probably you're right. Let me see. Yeah, right here. You got it. All right, guys. Here's how you figure out the class width. We got the largest value and the smallest value. My calculator is up here. I turn it on and find the range, the difference between the largest and the smallest, 52, 580. And once I get you started with this, you will know what to do next. Minus 3273. Enter. Okay. He wants 4 classes. 1, 2, 3, 4, as you can see. Divide this by 4. So you take maximum minus minimum and then divide it by the number of classes he wants. He has to tell you how many classes he wants. 5,576.75. Rounded up to the nearest whole number. If you round this one up, guys, it will be 5577. Remember this number here. I'm going to write it down. Okay. And now look, guys, how you construct the table. You start this way. If he doesn't tell you which one is which value to start with, you always start with the smallest value. But he says he wants you to start with 30,000. And now, guys, you're going to add 5577 to 30,000. So if you add 5577 to 30,000, that will be here what? Let me just type it.
Quick question. In the question itself, it says the class width is 6,000. So wouldn't that mean
he gave us the class width, so I didn't pay attention to this. So he wants us to use the 6,000. But it's anyway, it's good that I mentioned that. If he doesn't mention the class width of 6,000, guys, you will add the 5577 straight down. So 30,000 plus 5,577 will be 35,577. And then you will go here and add the same number, and then you add the same number. But since he says 6,000, so he's making it easier, actually. That will be a 36,000. And this one will be what, guys? 42,000. And this one will be what? 48,000. And can someone guess what the value here is going to be? Remember, there shouldn't be any overlap between those two values.
35,999.
You got it. Excellent. And then, guys, just add 6,000. It's going to be 41,999. And this one is going to be, guys, 47,999. And this one, just add 6,000. So it will be 53,999. Now, how do you fill this out, guys? It's easy. You already have it in StatCrunch. You figure out how many values are there between 30,000 and 35,999. Put it here, there, and then you have your frequency distribution table. All right. Okay. Another graph that I would like you to be aware of, which is a lot easier than a frequency distribution table, is called the stem and leaf plot. A stem and leaf plot, guys, let me clear this, is a graph that looks like this. You put the stem here, you break the number into 2 pieces, a stem and leaf. And let me show you the example he gives us here. Here's the data. Well, the data, as you can see, guys, it has tens and ones. So your tens is going to be the stem, and your ones are going to be the leaf. and then you would select one. Now, Static Crunch can do it for you. Let me show you how you can do that in Static Crunch. And then you go to graph and stem and leaf and variable 1 and hit compute. And here you go. So how do you read it? 4 with the 1 means 41. 4 with the 3 means 43. 4 with the 5 means 45, 46, 47, 48, 49, 49, and so on and so forth. You get it in Static Crunch, and guys, you go and compare which one matches with your answer, and that should be the answer right here. So that's what a stem and leaf is. All right. Misleading graphs. Okay, the graph on the right represents the favorite colors of 28 children. He's asking you, how do you think that this graph is misleading? What do you guys think? Oh, what did we do here? Well, sorry, let me do this. The graph to the right represents the cost of movie rentals. They show you bars, guys. Bargain rental is $1.25, regular rental is $2.45, and new release is $3.25. How are the bars are misleading? Do you notice, guys, that this bar at the bottom is almost twice the size of the regular rental? If it is twice the size, then the amount should be twice the amount. But that's misleading. They're trying to mislead you to figure that this is not the case. Look, 245, it's that much, and that's almost even more than double the size of this graph. So it should be about $4.90, but look what we have, $3.25. And it looks like the new release costs about twice as much as regular rental, but that's not true. You know, that graph is misleading. What could be done to improve the graphic? We should shorten the length of this one and make it probably up to here, guys. And then we can make it, you know, just not misleading graph. So this is an example of a misleading graph.
Real quick, the question before that one had a second part in terms of the shape of the distribution.
Okay. Let me see. Oh, we're going to talk about this. Let me show you this one. Now you see it generates a different question every time I go and back and forth. Can you guys, without looking at the answers, tell me how this one is misleading? He put Warm Springs 10 and Denton 7. Probably this costs $7.10. How this graph is misleading? It's obvious.
It's like 1/10 of the size when it's only like 3 units smaller.
You got it. Excellent. That's very good. That's exactly it. It looks like bakeries in Warm Springs are much larger than those in Denton. All right.
I was talking about the one before that one, the one from with the stem and leaf plot.
Yeah, I'll go back to it. Yeah,
oh, okay.
Okay, what do you think about this graph, guys? The safety manager at Bumbler Enterprise provides the graph shown on the right to the planner manager and claims that the rate of worker injuries has been reduced by 50%. So look, this is how this is misleading. You see this graph here? It looks like in 2002, they did good job. They reduced the size of the graph by 50%, which is the manager is trying to make a good impression. But actually, he's wrong, guys. And if you don't know statistics, you will never figure out that he's trying to mislead you. Well, how is this graph is misleading? I mean, it was 32%, and now it's 22%. But if the boss looks at this and doesn't look at number, is going to think that his manager is doing a great job, because he's going to see, like, you know, the size of injuries has gone by like 50%. And why 50%? Because there are 4 horizontal bars. And look, this is 2 bars here, and this is 4. But that's a wrong impression if the guy doesn't know statistics. Do you guys can tell where this graph is misleading? Based from your knowledge when you create graphs and construct the graphs. When you construct the graphs, what should this number be, guys? The intersection between the x-axis and the y-axis?
0.
0, but it's not 0 here. When it's not 0, the graph will be misleading. And now you know that. So it will be this. The vertical doesn't start as 0, and that distorts the percent. You see how people can mislead you in graph? Now, every graph you look at in a paper or an online, guys, check if the corner is 0. If it's not 0, this graph is misleading. Okay, let's see to your question that you asked me about. Let me see if I can get it back. Not this. Okay, this one.
No, that was the right one, the stem and leaf plot.
Oh, the stem and leaf plot?
Yeah, there's a
Behind it?
second part. There was a second part to it.
Oh, I see, yeah. Yeah. Construct a stem and leaf plot. So let's see, let me just show the complete answer here. Okay, so this is the graph. Now, he's asking you what shape the graph is, and I'm glad you mentioned this because it's, I think, time to revise the shapes. When you construct a frequency table, guys, let's say you have this frequency table. From 0 to 5, I have 7. From 6 to 11, I have 10. And then from 12 to 17, I have 3. This is called the class, and this is called the frequency. I think, guys, you've heard of histograms. A histogram is a bar graph where the bars are connected. I can use a distribution table to construct a histogram, and let me show you how I can construct this histogram. First of all, the vertical line is the frequency line. I need to go as high as 10. So I'm going to split it up 2, 4, 6, 8, and 10. And then the first class is 7, guys. So I'll do 1, 2, 3, and 7 somewhere here. The second one is 10. So I'm going to go as high as 10. And then the last one is 3. It will be somewhere here. 2, 4, 6, 8, 10, right here. How do we label the bars, guys? This is how we label them. If you go back and revise the book, they label them instead of writing 0 to 5 and then 6 to 11 and then 12. They take the middle of each class. 0 plus 5 is 5 divided by 2, 2.5. This one, guys, is going to be 80.5. And how do I know that? I just add the class width. The class width is 6. 0 plus 6 to 0 is 6. 12 to 6 is 6. So it will be 8.5. And this one is 14.5. This is what we call a histogram. A histogram, guys, can have many shapes. You could have a histogram that looks like this. And this is very, very important knowledge, the most important knowledge in statistics that you're gonna inquire right now. It looks symmetric. Symmetric, guys, looks like a bell-shaped, like this. This is the center of the data right here. So you can think of the center, this vertical line, as a mirror. The left side is reflected through the mirror on the right side and vice versa. This is what we call the symmetric histogram, symmetric data. So if your data looks like a bell-shaped, guys, it is symmetric. Now, here's another type of histogram that we call uniform. The bars have the same height. All of the bars have very much the same height. This is called uniform. We're not much interested in this, guys. We're interested mainly in symmetric. But there are two different shapes. Let me explain them to you. One that looks like this. Skewed. It's a skewed data toward the right. You can see there is a tail toward the right, guys. This is what we call right skewed. And now let me show you left skewed data. Something like this, guys. There is a tail toward the left. This is left skewed data. Okay. Now, this is our graph. This is our histogram right here. If you guys, I would like you just to imagine something. If you rotate this stem and leaf plot 90 degrees counterclockwise, what does it look like? Symmetric, uniform, skewed left or skewed right? If you turn it, guys, 90 degree this way, it's going to look like this. So what does this look like, guys? Do you agree it's bell-shaped, which is symmetric?
Yes.
Yeah, that's what distribution of data. So your distribution of data, we're going to assume later that distribution of data is always bell-shaped, but there could be 4 different distributions. You could have uniform, you could have skewed right, skewed left, bell-shaped. In real life, guys, most of the data that we collect, it turns out to be bell-shaped. Good question here. Okay. I thought I set it up. Doesn't ask me, but it keeps asking me. All right. Now let me clear. We're in chapter 3, guys. Mean. Mean is the average. You learn, guys, in high school or in statistics that you learn about the average, but now in statistics, you have to know that there are 3 different averages. One is called the mean. One is called the median, and one is called the mode. They call them measures of center because they measure the center of data. How do you calculate the mean? You add up the value and you divide by the number of values. How do you calculate the median? You sort the data in order and you pick the value in the middle. The mode is the value that occurs most often. Now, if your data comes from a sample, guys, and most of the time it is from a sample, your mean has a name, has a label, which is X bar. But if your data comes from a population, it is the entire population. If your data is the population itself, your mean has a different label, Greek letter, they call it mu. This is how we write it down. Now look here what he says. He says population, right, guys? So when you choose the answer, you have to choose this one, mu, not X bar. Otherwise, even if your number is going to be correct when you write it down, but you have to use the proper symbol, which is mean, because he says population. Now, how do you do this? Using StatCrunch. Watch, guys. This is the magic of technology. Open in StatCrunch. And I want to clear everything here so you can see. You go to Stat. In chapter 3, this is actually the formula that you use. Summary statistics, columns. Select this column because the data is in it. And just hit compute, guys. That's it. And look, this is the mean, 13. Not only it gives you the mean, it gives you the median, which is 16. It gives you the range. The range is the difference between the largest and smallest value, but that will get to that. But it doesn't give you the mode. You have to figure out the mode by yourself if there is a question about the mode. So now here, when you enter the answer, guys, you don't put X bar. That's wrong. You go to this and put 13 right here. And that should be your answer. Fantastic. Okay. Now, we need the mean. Okay, guys, you can do this in StatCrunch. Watch. And I'm going to show you how to use the calculator for this as well in a second. You go to Stat, Summary Statistics, Columns, select it and hit Compute. That's it. You don't do anything else, guys. And look at the mean, 69.888. Let's see here what he wants you to do here. How many decimal places? Okay, so we're gonna type it here. He says, type an integer decimal rounded to the nearest tenth. So 69.9. Was it 69? I forgot. Yeah, probably it was. And then you check the answer. Well done. And let's see what he's asking us. Determine the sample mean pulse of the following two simple random samples of size 3. Kathy, Crystal, and Perpetual. Kathy, so this one 72, 69, and Crystal, which is 76. Okay, calculator, guys, watch. We can do this on the calculator. First of all, you have to enter the data into the calculator. Here's how you enter data into the calculator. This is very, very important. Any data that you want to process in the calculator, you have to put it in the calculator like that. Stat, edit, and you put it in a list. And he says, Kathy, Crystal, and PIMF. So 72. Look, I just type it, 72. I press enter. And then Crystal is 76. And then Kathy is 69. I mean, you could do it by hand, add them up and divide by 3. But let's say, what about if you have more data? And then you guys go with stat, calc, one variable statistics, press enter. Okay, the calculator is confirmed. Is your list in L1? Yes, and just hit calculate, guys. And now it's giving you the mean, 72.3. And I'll just go here and type 72.3 and check answer. See, we're good. And then sample 2. The sample 2 is asking me for Jeff, Clarice, and Crystal. You just do it and get the answer like that. But for sample 2, you have to go stat, edit, and re-enter the values. This is how you clear the list, guys. Just go to select with the right arrow, up arrow, select L1 and hit clear and enter. And now you can enter the new information. All right, so this is how you use your calculator. And this median. Compute the mean, median, and mode. Well, guys, now let's go to the calculator. Let's go to StatCrunch and do it there if you like. You go to stat, summary statistics, columns, selected, and hit compute, guys. As simple as that. Look, this is the mean, 97.1125. Median is the value in the middle, which is 97.5. Mode, you have to figure it out on your own. So if we just go here, do you guys see any numbers that repeat more than once to consider them as the mode? I don't see anything. So you just say no mode. There's an example where there is a mode. Let me just give you an example where there is a mode. Can you guys tell me what the mode is?
7.
Yeah, 7. It repeats it. No, 3. 3 repeats 2 times. 7 repeats 3 times. Okay, so you say the mode does not exist when you answer this question. And if you use your calculator, guys, you can do so as well with the calculator. Just put the numbers in L1 and run stat, calc, one variable statistics. It's going to give you the mean, mode, and median, which we're going to see that in a second in another exercise. All right. So that's section 3.1. All right. Now, please pay attention to this. That's important. If you have a data that looks like this, bell-shaped, so the histogram looks like this, guys, the mean and the median and the mode are the same. They are all in the middle. And why the mode is the same as the mean? Because the mode is the one that has highest frequency. So the highest peak of the mountain is right there. So that's the mode. That's for symmetric data, bell-shaped. Now, if you have a distribution of data, guys, that looks like scoot to the right, like this. And here's one question that I ask guys always on this. I put 3 values there, A, B, C. And I ask students the following. Which one is the mode, which one is the mean, and which one is the median? Look, for the mode is very easy. You follow the letter that's fall below the peak of the summit rate, which is right there here. So it's going to be the mode. Now the question is, which one is the mean and which one is the median? I'm going to give you the hint. The mean, if your data is skewed left or right, the mean always closest to the tail of the distribution. This is the tail, guys. That means C must be the mean because it's closer than B to the tail, and that will be the median. Now, if you have data that is skewed to the left, and let's say I give you 3 letters, guys, and I ask you which is which, right away, guys, you're going to tell me C is the mode. And then because A is closest to the tail, that's going to be the mean. And that's the mode. And that's the number line, guys, going from left to right. So in a distribution that is skewed right, the mean is bigger than the median always. You select this one. And if it is skewed left, the mean is less than the median. And if it is symmetric, the mean equals the median. Does that make sense? All right, clear. Okay. Now, we'll be done in a few minutes, guys. Just bear with me. There's just 2 of you, but I'm fine, guys. If I can help 1 student, I'm happy with this. Let me tell you what the standard deviation is. Okay. Let's take this data set. Sorry. Okay. And I'm going to put it into the calculator. So let's do that to be ready. So we go to stat, edit. Oops. And let's enter. If you want to enter it with me on your calculator, that will be fine. 2, 3, 4, 5, 5, 7, 8, 9. All right. We can find the mean. We can find the median. Let's find the mean. Stat. 1 variable statistic. Enter. And scroll down to calc. Enter. And the mean is 5.375. Let's make it 5.38. So okay. Let me tell you what the standard deviation is. This is very, very important concept in statistics, guys. It's extremely important that you understand what the mean is and what the standard deviation is. Okay, I think you've heard of standard deviation before, but let me explain it to you. The standard deviation measures how far apart each value on average is away from the mean. How far apart each value is from the mean. Like 2 is below the mean, as you can see. 3 is below the mean. 4 is below the mean by 1.38. 5 is below the mean by 0.38. 5 is below the mean. 7 is above the mean. We want to know on average how much does each value deviate from the mean, or in other words, how consistent those values are with the mean. We find the standard deviation. So that's what we call a standard deviation. if I find a standard deviation of a data set, guys, and it is 0, that means all the values are exactly the mean. For example, if you take this data set, 5, 5, 5, 5. If you find the mean, it's going to be 5. Well, each value deviates 0 from the mean. That means the standard deviation is 0. So the standard deviation is a measure of consistency. The lower the standard deviation, the closer the values are to the mean. The larger the standard deviation, the more widely spread the values are from the mean. And actually here, you're going to notice that the standard deviation is going to be quite big because the values deviate from the mean. We have values that are 3 points away from the mean and values that are 4 points away from the mean. Okay, there are two simples for the standard deviation. If you are using a sample, guys, usually it is a sample, the standard deviation is called S. If you are using a population, and here he says as a sample population, the standard deviation is called sigma. We write it, it's a Greek letter. We write it like this. So when you see this, guys, this is a population standard deviation. When you see that, this is a sample standard deviation. We put our data into our calculator. Let me show you first of all how I can use the calculator to find the standard deviation. Watch, you already actually did, guys. We already did. This is the mean, 5.375. S is the standard deviation, guys. Now, why he puts S in sigma? Because the calculator doesn't know what we input, whether it is the population or not. We know it's a sample, so my answer will be 2.45. That's my standard deviation. This is the minimum value, guys. This is the median, which is 5. And this is the maximum, which is 9. And I'll talk about Q1 and Q3 when time comes. Now, you can use two standard deviation, guys, using StatCrunch. Watch. Open in StatCrunch. Go to Stat, Summary Statistics. See, that's the only feature I'm talking about today. Variable 1 and hit compute. And watch, guys, what happens. Look, this is the standard. This is the standard deviation. 105.6. It's a different question from the one we did. That's the mean. That's the median. That's the minimum, maximum. Range is the difference between the lowest value and the largest value. So 455 minus 219. And we'll talk about Q1 and Q3 in a few seconds. Now, let me tell you what the variance is. Variance is the square of the standard deviation. So it has two simples as well. So annotate. One simple is S squared. That's the variance from a sample. And sigma squared, that's a variance from a population. We will be using S squared most of the time because most data that we have comes from a sample. So you can, guys, use StatCrunch also to find the standard deviation. All right.
Will StatCrunch be available during exams?
It will. Since we're not taking exams on campus, it's going to be. That's why. That's a good question. I'm emphasizing on both of them. So I'm going to give you the option to use both. But the calculator is recommended, guys. There will be some questions later, especially when we do statistical analysis and the heavy chapters. The calculator is a much better option. So calculate the range and the standard deviation, guys. Watch. Open in StatCrunch. Look how easy it is to do it. And I don't require that you do any work by hand. All I need, why did it do this? Oops, that's coming. Can you guys still see the screen, right?
Yeah, we can.
Yeah, okay. So you go summary statistics, columns. I don't know why it did this. Open so many windows. And let me show you guys. And then hit compute and watch. What did he want? The standard deviation and the variance. This is the standard deviation, and that's the variance, guys. You get them all. All right. Let me just close this. So, all right. So we got this one, and Let me go back. Okay, so that's the one that we were working on. Okay. So the range, and then you can, okay. This one, just a couple more. Let me explain this one, guys, here. This is a bell-shaped curve. Let's say you do a data and it has a bell-shaped. The mean is always here, guys. Let's say the mean he gave us is 50, and let's say the standard deviation is 10. Let me tell you something about the standard deviation. For example, guys, let's say if I ask 50 students, how much on average you spent on gas a week? So that they tell me $50, and then we figure out the standard deviation. The standard deviation is $10. Look what I can conclude. I conclude that it is very unlikely that there will be students who spend more than $80 and less than $20 on gas each week. Let me tell you why. Because in real life, you don't go 3 standard deviation beyond the mean, and you don't go 3 standard deviation more below the mean. So all data, guys, has to be confined within 3 standard deviation of the mean. So if I add a 10 to 50, I'm at 60. Then if I add another 10, I'm at 70. And if I add another 10, guys, I'm at 80, which is the end of the, almost the end of the distribution. The bell-shaped doesn't touch the x-axis, but it's almost touching right here. And if I go this way, guys, $40 less. Where did I get the 40? It's the standard deviation. 30 and 20 should take me to the end of the curve again. In statistics, guys, 99.7% of the data should be within 3 standard deviation of the mean. We miss only a 0.3%, which these could be outliers, extreme values. So, and 95% of data, guys, should be within 2 standard deviation of the mean. So if I ask you guys, what values are would make 95% of the data set, you will tell me any values between 30 and 70. And how did I get 30 to 70, guys? I added 10 and 10 to 50, and I subtracted 10 and 10. That's a 95% of the data. Now, what are the values that make 68% of the data? It's within 1 standard deviation of the mean. So if you add 10 to 50, that's 60. If you subtract 10 from 50, that's 40. 68% of the values are within 1 standard deviation of the mean. And this is called the empirical rule in statistics. They call it 68, 95. If you go to Google, to YouTube, and just put empirical rule, you're going to get thousands of videos explaining this. 60-80% means 1 standard deviation within the mean. This is 2 standard deviation, and this is 3 standard deviation. So if I have a student in my class, guys, whose scores are always more than 3 standard deviation above the mean, you know what I would tell the students? Quit the class. You don't belong here. You're too smart, you know, for this class to be in this class. That's what, because usually when you go above the 3 standard deviation from the mean, you're on the very, 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 very top. But if you go more than 3 standard deviation below the mean, you are at the very, 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 very bottom. So that's an area of concern too, as well. Okay. So now, what kind of questions I could ask here? Let me show you a question. I could give you this data set. I'll tell you the mean is 70 and the standard deviation is 5. And I tell you the distribution is bell-shaped. And I ask you this very simple question. What percent of the values are between 65 and 75?
99.7.
No, between
65
and 75. So
95%.
I subtracted one standard deviation and I added 1 standard deviation. And you just, there are three numbers you have to choose from, guys.
68, 95,
Yeah,
97.
68, it's just a 68. Because 60-80% of the values is one standard deviation below and above the mean. Let me change this one and make it 60 and 80. Then you guys, you look at it, you say, well, the teacher says 60. I know 60 is 2 5s below 70. And I know 80 is 2 5s above 70. When you do two standard deviation is 95%. And let's say I change this one now to 55 and 85. So you know that I'm going 3 5s below 70 and 3 5s above 70. That should be the 99.7%. This is called the empirical rule, guys, in statistics. All right. Let me just. Okay. This one. Z-score. That's very, very important in statistics. And you guys, you need to review this. I cannot say, please pay attention to this. The Z-score. Let me tell you what the Z-score, we already talked about it. Let's say we have this data set. The mean is 50 and the standard deviation is 10. So that's 60, that's 70 and goes to 80. And here it goes to 40, 30, 20. Let me ask you a question, guys. Take 60. How far apart is 60 from 50? Who can answer this question?
10.
10. How many standard deviation is this?
1.
One standard deviation, because each standard deviation is worth 10. The number of standard deviation, the value deviated from the mean is called the Z-score. So the Z-score counts how far apart the value is from the mean as far as standard deviation. If you take 70, guys, you agree that the difference between 70 and 50 is 20, which is 2 standard deviations. So the Z-score is 2. If you take 80, the standard deviation, the difference between 80 and 50 is 30. And 30 means the 3 standard deviations. So the Z-score measures how many standard deviation a value, by how many standard deviation a value is apart from the mean. But if you go here, guys, 30, it is 20 below the mean, which is 2 standard deviation below the mean. The Z-score is negative here. So you say the Z-score is -2. Here, the Z-score is 0. So that's something I would like you to focus on in section 3.4 when you do the Z-scores, guys. Very, very important. And how do you calculate the Z-score, guys? You don't need to guess it just like I'm doing it. There is a formula. The Z-score is the value minus the mean divided by the standard deviation. And let me show you what this formula makes sense. Take the value 60, guys. We agree that the Z-score is 1. So look, put 60 here, minus the mean, which is always fixed at 50, and the standard deviation is fixed at 10. 60 minus 50, guys, is 10. 10 divided by 10 is 1. The Z-score is 1. So if I, guys, come to you in a couple weeks and tell one of you in this meeting, Ahmed, I tell you, Ahmed, your Z-score was 2.5 on the test. Should Ahmed be happy about this? I think Ahmed should be very happy because he is more than 2 standard deviation above the mean.
Does that mean you're going to tell me I'm too smart for the class?
No, but you're going to go beyond the 3.
Okay.
You're going to go beyond 3. Then, if I tell Ahmed your Z-score was -1.1, should you be concerned, Ahmed, or not about your grade?
I should.
Yeah, because -1.1 means you are at least 1 standard deviation below the mean. That means you are performing a lot lower than the average of the class. That should be an area of a concern. If I tell Ahmed that your Z-score is 0, that means Ahmed is right at the mean. When your Z-score equal to 0, that means your score is exactly what the mean is. When a Z-score, guys, is bigger than 2, or a Z-score less than -2, the value is unusual. You see, you start going to the unusual once you go beyond 2. if a z-score is more than 3, guys, or z less than -3, we say that the value is very unusual. And this is where we will have Ahmad, if you go beyond the 3, we'll have to tell you probably you don't belong to this basic statistic course, take a higher one. And that's what, but if the z-score is between -2 and 2, guys, then the value is usual. It is usual. And let me just do this exercise to show you how to compute z-scores. In a certain city, the average 20 to 29-year-old man is 69.6. So the mean is 69.6. Standard deviation is 3.2. While the average, the women here, the average for women is 64.5, standard deviation is 3.9. So we have men and women. Who is relatively taller, a 75-inch man or a 70-inch woman? You guys, you cannot say that it is the man who is taller because he's more than 70. He says comparing to their own group. So if someone has an ACT score of 21 and another one have an SAT score of 500, who did better? I can say the 500 because the criteria is different for each one. So in order, just to compare apples and oranges, which usually we can't, but we can if we change into a z-score. So what I'm gonna do, guys, I will change the 75 to a z-score, the 70 to a z-score, and the one who have a higher z-score will be taller. So for the man will be 75 minus 69.6 divided by 3.2. For the woman, it will be 70 minus 64.5 divided by 3.9. And if you do the math, guys, right here, let me see what you get. If you can do it with me, 75 minus 69.6 equal divided by 3.2. I got a z-score of 1.69. And now for this one, 70 minus 64.5 divided by 3.9. I got 1.41, and now we know what the answer is. So the man is relatively taller because he got a higher z-score. Okay, so that's clear. And then move to very last two questions, I believe. Okay. What is Q1 and Q3? If you have a data set, guys, if you have a data set, the value in the middle is called the median. And they call it in statistics the second quartile, 50%. At 50%, they call it Q2, second quarter. If you do 2 quarters, guys, you get 50 cents, and that's why they call it second quartile. Now, if you take the first half, guys, and find the half of the first half, we call this the first quarter. So it's a half of the first half. And then if you take the second half and find its median, it's a half, that we'll call it Q3. So Q1, Q2, Q3, this one is always called the minimum value. And this very last value, guys, is called the maximum value. And the 5 numbers together are called the 5-number summary. So your calculator can do them. So this is located at 25%. This is located at 50%. And guys, you can guess that this one is located at the 75 percentile. Okay, this is what Q1, Q2, and Q3 mean here.
And then quick question with the quarters. Do they relate to the standard deviations at all in terms of like
No,
Q1
no,
and Q3?
no, they don't.
Okay.
So determine the standard deviation, guys. Look, watch. I would use StatCrunch for this, definitely. Open in StatCrunch. Stat summary statistics columns, and watch, guys. All right, he wants the standard deviation. Here's the answer, 75.6. Now he wants the interquartile range. Let me tell you what the interquartile range is. The difference between Q1 and Q3. It's called, so you already have a Q3, you already have a Q1, guys. You subtract them and you find IQR. The system doesn't do it. So now we're introducing you to this interquartile range. We'd call it IQR, which is Q3 minus Q1. All right. I know you're getting tired of listening, but I'm doing it for you guys. So just bear with me until we finish this. I think we have a couple more questions. And I'm getting to the end of this. Okay. 5-number summary, guys. It is the minimum, Q1, Q2, Q3, and maximum. So if I ask you to find the 5-number summary, this is how you do them. Q1, guys, they call it P25, 25th percentile. 25th percentile, guys, means 25% of the data are below this value. This is called the 50th, and this is called the 75th percentile. Okay, and let's move on. Okay, and this is available. You can see the homework. You can, okay. For a distribution to be skewed left, okay, let me just move on to do. Okay, finally, guys, the last thing I want to show you. Let's say you have the 5-number summary, minimum. Let's put some values, and that would be the last thing. Let's say the minimum is 10, Q1 happened to be 14, Q2 happened to be 21, Q3 happened to be, it's going to be larger definitely than Q3, 30, and the maximum is 40, guys. And he asks you to construct a box and whisker plot. A box and whisker plot need the 5-number summary to do it. Here's how you do it. You draw a number line. You put all those values on the number line, but you scale the number line. We need to start at 10 and end at 40. If I were you guys, I'll do 10, 20, and scale it properly, 30 and 40. Then I'll go to the minimum, which is 10. I'll put a dot right above 10. Then the Q1 is 14, so it's halfway below the half. That's 14 right here. Then 21, it's a little bit over 20. Then 30, guys, and then what? 40. You connect the last 2 dots, you connect the first 2, and here you draw this vertical line, vertical line, vertical line. And this is called the box. This is the box and whisker plot. If the whisker is longer toward the right, we call it a right skewed distribution. If the whisker is longer toward the left, we call it a left skewed distribution. And actually, guys, if you have data, you don't need to do it by hand. Your StatCrunch can do it. You just open in StatCrunch and show you how to construct the box and whisker plot. And I'll stop there after that. Graph. You see where it says box plot, click on it, variable, compute, and here's the box. It's vertical. I'm gonna make it horizontal just to show you exactly what I did. So let me just change this. And I want to finish right before 5. So graph, box plot, draw boxes horizontally, look guys. And quit. Select, you have to select the variable always. So now you learned how to use StatCrunch. And here you go. It looks kind of skewed toward the left, guys, as you can see right here. And these are the values. Look. They even tell you, okay, one more thing I didn't do, which is outliers. Just you'll learn it in section 3.5 as you do the interactive assignments. See, when there is a dot, here, this is an outlier. An outlier, do you guys know what an outlier is? An outlier is that is a value that's far removed from the data set. It doesn't seem to belong there. For example, guys, if I ask you how much on average do you spend on lunch, and then you tell me $7, another student says $6.50, then one say $4, one say $3, one $5, one $1, and then another students tell me $50. This 50 doesn't belong there. Probably this guy went to a fine dining and ate sushi, you know, just for lunch. But the rest of them seem to be consistent. This is called an outlier.
Is there a certain amount of like standard deviation?
Oh, definitely. There is a process that time is not going to permit for me, but I have a video showing you how to find outliers. There is a process, 2 steps. I'll have you, I think probably you guys are getting tired. I'll send a video for how to check for outliers. And the author, when you do the interactive assignment, is going to show you. But that's a good question. The last thing I want to tell you guys, if you have this data set, two, 3, 3, 5, 50. What's the median of this data set? It's a 3, right? The value in the middle, correct? What's the mean? If you find the mean, guys, you have to add 2 plus 3 plus 3 plus 5 plus 50 and divide by what? By 5. Let me see what the mean is going to be. 5 and 3, 8, 13, 63 divided by 5 is 12.6. And guys, you agree that the median is 3. Let me ask you a question and then I'll close here. And that's the mean. Which one is a better representative of the data set, the median or the mean? Which one is a more accurate representative of our data set? This is our data set.
The median.
Why not the mean, Ahmed?
Because of the outlier, it skewed the median. Or the mean.
In the presence of extreme values, guys, the mean is a very bad representative of the data set. Look, most of the data are 2, 3, 3, 5, and we're talking about average 12.6. That's not right. So guys, in real life, if you want to be honest when you do statistics, if you have extreme values in your data set, don't use the mean. You will be misleading people. So we say that the median is resistant to extreme values, but the mean is not resistant to extreme values. And I will end here, guys. I'm gonna